Today topic is ultracentrifugation. Ultracentrifugation is used to denote analytical ultracentrifugation, which is used to analyze biological molecules like macromolecules. What are the macromolecules like proteins, and using specially designed centrifuges are used to detect the proteins, which can separate into multimeric states based on the sedimentation rate. These procedures a molecular weight profile of compounds by which multimeric state of that molecule can be known. Here the monomer, which is small molecular weight compound, and dimer means double monomer. Double monomer which is equals to the same molecular weight of compound which two compounds likewise, and the equilibrium analysis can also be performed to provide the dynamic equilibrium information, that is association or dissociation rate of multimeric state. The two types of analytical ultracentrifugation are there, which are said to be sedimentation velocity area under curve and sedimentation equilibrium area under curve. Sedimentation velocity analytical ultracentrifugation is performed to obtain sedimentation coefficient values. Here the sedimentation velocity analytical ultracentrifugation, shortly we can call as SVAUC, is used to perform the sedimentation coefficient values and percentage of monomer or multimer components in given samples, and sedimentation equilibrium analytical ultracentrifugation, which is shortly denoted as SEAUC, used to assess interaction and dissociation between sample components. Principle of ultracentrifugation compounds is when a mixture of protein in solution is centrifuged under high speed like 40,000 to the 60,000 rpm rotations per minute, a centrifugal force of 2,50,000 grams gravity is achieved. Due to this, we can apply the centrifugation force 2,50,000 gravity to a solution under high speed rpm 40,000 to 60,000. Due to this, sedimentation and separation into multimeric states occur. The sedimentation and the separation will occur. The mass of a molecule, the mass represents weight of high rpm conditions, and a profile of molecular weight compounds takes place, and we can analyze the transparent cell online, which represent rotor based on the measurement of absorption or refraction. Advantage of this method, we can separate the wide molecular weight ranging from several hundreds to several millions. For example, sucrose, proteins, carbohydrates, nucleic acids, several large molecules can be separated by this method. The substance should have different absorption index compared to the solvent. Sedimentation equilibrium methods require only for the small sample sizes and having low concentrations. The sedimentation depends upon the size and shape of the protein. Sedimentation process governed by the three factors, which are gravitational force, buoyancy, and hydrodynamic friction. Here comes to the instrumentation of ultracentrifugation. A typical analytical ultracentrifuge, which is also called as Beckman coulter, is specially designed equipment which has rotor which can rotate up 40,000 to 60,000 rpm rotations per minute, already discussed in principle, which can produce the 2,50,000 gravity. The cell which hold a sample of volume between transparent windows used to pass UV visible light detection based on the property of compounds. For example, aromatic amino acids having a wavelength 280 nanometers, that is used for the peptide backbone, which having wavelength 230 nanometers. And based on the compound, the analyzed detection can also be using laser interferometer based on the refractive index difference. The diagram shown that having light source and sample is there, and the rotor which rotates the solution, and a detector which detect the readings. The below mentioned diagram shows a plot of different zones absorption, like solvent meniscus, sample meniscus, boundary region, and we can observe the graph between sample and absorption. The sample absorption, how much, like it is like a slope, when it is come from slow to high peaks, and then it will be stationary, and then it reached the peak. Uses of ultracentrifugation is centrifugation used to examine the sample purity and molecular weight, to determine the molecular weight of sample, and some analysis, pharmaceutical analysis will be taken the ultracentrifugation, and sedimentation process contains ultracentrifugation, and ligand binding also one use of the ultracentrifugation. And another topic is X-ray diffraction. We already know so many types the X-ray diffraction, X-ray taken by the when fracture is occurred, and sometimes the bone damage or joint destructions will occur. Then we go to the hospital or any laboratory, we can take the X-ray of that particular area, and we can find the damage of that bone or a joint. By the X-ray diffraction, it is a technique of compounds. We can diffract the X-ray wavelength. The X-ray diffraction, it is a technique which is used for the detection of the qualitative analysis and their structure, how it is internally, and what is the structure elucidation of organic and inorganic compounds. In pharmaceutical analysis, the X-ray diffraction used for the structure elucidation of organic and inorganic compounds. The X-rays are passed on a crystal. If we place a crystal, then X-rays will be passed on to that particle. The X-rays are scattered the atoms and then they arranged. The atoms are arranged in a plane with a particular distance, for example x, y, z. When X-rays of wavelength similar to interplanar distance falls on the atoms, they diffract due to constructive interference. The recorded photograph film are measured using X-ray detectors. For the examples, interpretation of pattern gives information on various aspects of the compound. We can easily give a equation, Bragg's equation, which denotes the X-ray diffraction. That is here the formula, Bragg's equation. Integral n is called as integer. Lambda, wavelength of X-ray used. D for distance. Sin theta, theta is angle of incidence. We already know that. Here the diffraction of X-ray of a crystal we can observe clearly. Here the incident beams will pass through a plane and the surface of crystal is there. The angle is theta. Then the diffraction beams are placed here on the plane. Incident beam and diffraction beams are having a angle 0. The two are meet on a plane that denote as a theta, another theta. AB plus BC is equals to multiple of n lambda. These two planes are placed in crystal. Here comes the Bragg's equation. N lambda is equals to AB plus BC. AB is equals to BC. Hence, N lambda is equals to 2AB. According to equation 1, sin theta is equals to AB by D. D sin theta is equals to AB. 2D sin theta is equals to 2AB. Here same, n lambda is equals to 2AB, sin 2D sin theta is equals to 2AB. Equation number 2. These two equations are based on the equation 1 and 2. N lambda is equals to 2D sin theta. When we know the wavelength and theta, the value of D for distance, that is spacing between the planes within the crystal, can be determined. The space between the planes 1 and 2, the distance, we find this distance. Instrumentation. Here comes to the instrumentation. X-ray are produced when high speed electrons collide with a metal target. When a high speed of electrons collide with a metal target, the high speed electrons are generate hot tungsten filament, which is also called as cathode. And after applying a high accelerating voltage, here metal target is placed here. The X-rays will collide to this target, then it fall to the copper, then it's transfer from the copper or aluminum. Water is circulated in coolant to copper block containing desired target material. Here water is passed through here. It cools the metal target and the X-rays will pass to this metal and the transformer transfer the light, which is how we prepare the sample. Here the ideal situation we observe this. Ideal situation. Sample analyzation is more important in this one, and here the single crystal cross section is 0.3 micrometers. In case of powders, the ground particle size of compound is 0.002 to 0.00 millimeters and compressed to present in a sample film holder. In some XRD instruments, the sample holder is fixed while source of detector is rotated, and sample holder can be rotated while X-ray source is fixed position. The detector is used to capture the X-rays, diffracted X-rays, which produces signal and recorded. The signals will be the signals which came from the diffracted X-rays that detected by the detector and recorded by the recorder. Alternatively, a photographic film is placed around the sample and that diffracted X-rays produce an image that form a pattern. The pattern is unique, like fingerprint, which unique from the each one to different crystals and serves this identifying mechanism. In some models, the detector is capable of rotating and signal captured. Here the detector is not rotated by the fixed position, and the recorder recorded the signals and then interpretation will be occurred. The signal from the detector is recorded and the pattern of diffraction is captured in a photographic film. This is unique, we already discussed. XRD signals are like how it is means I will show in diagrammatic view. This is the XRD diffraction pattern. We can observe here the graph is placed between diffraction angle and intensity. The diffraction angle is 30, then it will reach to the 111 here. Then diffraction angle is 32, like that it crosses the 100. Likewise, the peak will be observed by in the XRD pattern. Here we take a sample of NaCl powder, and then the typical components of XRD instrument is X-ray tube is there, and incident X-rays are passed through this crystal, and the angle is 2 theta measured. The diffracted X-rays are diffracted by the detector and it will be recorded in, it can be photographic. By what is the use of XRD means it is used for the amorphous materials and polycrystalline compounds. It is easiest technique to find distance of crystals, and separation sample preparation is easy in this XRD, and XRD patterns are available in database. And pharmaceutical other related uses, how it is used in pharmacy means it is used for the geological applications and environmental science, pharmaceutical industries, and chemistry for the forensic sciences for detection of the fingerprints, like I already told you that what it is means joint fractures. Here we can the drugs examples are carbamazepine, enalapril are used as XRD diffraction. Thank you.